All right. This one here is war story stuff, and the name of this article is one that I wrote called Improper Fluid Transfer. Incidentally, this is your old forestry instructor, one of the vehicles here. It's one that we worked on probably 2-3 years ago.
The Ranger?
No, the Ranger, we worked on that one too, and he had driven that thing through somebody had driven it through so much muddy, salty water or whatever that everything under that truck was rusted slam out. And park brake cables were rusted, all the brake parts were rusted. It was just horrible, and we had to rebuild everything under that. He had a pretty big bill on that too. But I grew up down here in South Alabama, and so I used to go around the trafficking with my buddies on this little Welch pony that I had, a little mountain horse, mean little horse that'd kick you and bite you and all that kind of stuff. But these old timers always used to share all kinds of information that I felt was unnecessary, that I wasn't particularly interested in. And they would hold up a piece of farm tack, like a little rusty thingamabob of some kind, and they'd say, "I bet you don't know what that is." Well, how in the Sam Hill am I supposed to know? It's just a real rusty piece of steel. And it would be some sort of piece of harness on a mule or something that from 100 years ago, and unless you were really familiar with that, there's no way you could know what it was, And I don't know how many times that happened. I'd be in a barn somewhere with some old farmer wearing overalls and all that. But when I started working with grease and steel, these same old timers would grumble and talk about when cars still had headlights, the time when headlights were still mounted above the fenders, and how everything was a flat head and wheels had spokes, and they joke about old Fords not needing brake fluid because brakes were mechanical, and they didn't happen to have any brake fluid for a Model T or whatever. But it didn't take long, though, for engineers to recognize the fact that you could take a hydraulic piston, put it behind a brake pedal, and snake those brake lines over there and have hydraulic pistons that would act on pressure, and it was a heck of a lot easier than making that. But these old Hudsons, like Donnie's got a 50 model Hudson over at his shop. He had it up on the lift one day, and I was looking under that thing, and they actually had mechanical brakes on that Hudson that would take over if your hydraulic brakes failed, which is pretty interesting. That was in 1950, that one did. But anyway, if you can snake a steel brake line over there with some pressure modifications for vehicle weight distribution, then use leverage, stroke, and disparity in input and output, a car could be stopped without mechanical linkage. Now, the brake you pull up between the seats, what do you call that?
Emergency brake.
Wrong. It's the park brake. It's not really worth a flip for emergencies. It'll get you past something. But if you have to stop the car quick, that brake ain't the way to do it. Now, handbrake turns and stuff, I guess, like they do, secret agents do. But anyway, fluids transmit movement because you can't compress them. And they can facilitate heat transfer, by convection. In other words, they convey the heat away. They absorb it from a hot component, and when moved to a compressor or pump, they carry it to an exchanger. We talked about that the other day. All right, but the one unifying element of using fluids to do work is the fluids have to be contained. So you got to keep them, because if they leak on the ground, you're going to wind up without some. Now, what's the only thing that should ever legitimately leak out of a car and hit the ground?
Water.
And where should it come from?
Air conditioning.
And I know one more place, the tailpipe. When you crank it up cold, there's going to be water dribbling out of the tailpipe. But this customer that I'm going to talk about first had a problem with a power loss / flashing malfunction indicator light, which even to newbies means a type A misfire. So if it's flashing the check engine light, that means it's a catalyst to damaging misfire. And while the PCM generally shuts the injector down on the guilty hole, the catalyst can be damaged if the condition is not corrected. See, what if the injector is mechanically damaged to the point to where it's dripping fuel in there? If the PCM shuts off the power to that injector, that won't make any difference. You're still going to have gas going in there, and it can still damage the catalytic converter. And since the catalytic converter is covered under warranty for 8 years or 80,000 miles, or on a lot of these cars, I think it still is. I think it's a federal mandate. I might have to look that up nowadays because things change all the time. But the fact is, they don't like having to come up with a replacement catalyst because of a damage, and so they tell you to stop driving it if the misfire lights. Have you ever seen a flashing misfire light? A flashing check engine light. Whenever you got a really bad misfire, it'll flash. And that's like more than a certain number of misfires every 200 in a 200 RPM window. Okay, well, she bought the Expedition used, and she took it to her mechanic a couple of weeks earlier, and he said he either replaced a coil or the coils. She wasn't sure. So this one had coil packs, instead of coil on plug. It didn't have coil on plug. It had, multiple coils made into packs and all that. So it was one of the older ones. And neither assembly looked new. Neither one of those looked new. She said they put it on there. Now, he may have got one off of another engine he had or something like that. Well, but they were just dusty. How when a part's new, you can tell it. When you look under the hood, you can tell it's shiny, it's new, it's clean, and all this. And both of them look just as dusty as they've been on the dirt road, and it hadn't had time. And he could have replaced the pack with a used one, but she paid a pretty good bit of money for it. She told me. Well, I connected the scan tool, got three codes. Both banks were showed to be running lean, and the number 4 cylinder was misfiring. 2 lean banks, and the number 4 cylinder misfiring. Well, it's not smart to go after lean exhaust codes when a cylinder's not firing. Why is that? Daniel, if a cylinder's misfiring, what's the oxygen sensor going to read? Let's say that you got a bunch of raw gas going in there and all that.
Read rich.
No, it'll actually read lean because the oxygen's what it's smelling. It don't know about fuel. Think about it. What kind of sensor is it? Oxygen sensor, for the most part. So, and that's a mistake everybody makes. I've been in classes full of mechanics, and the instructor would ask that question. These are guys that work on cars every day, all day long, and they'd say, if I got a misfiring cylinder, what's the oxygen sensor going to see? And the mechanics would all say, it's going to show rich, because they're thinking gas fumes and all this kind of stuff. Here you go.
I thought I just read that voltage based off heat.
Well, it's actually not heat. Well, I'll take it. The titanium oxygen sensors that some of the Jeep Cherokees had, when a cool exhaust is rich and a hot exhaust is lean, and so it would use the temperature of the exhaust to determine, and it had a variable resistance based on temperature that was really fast. But the rest of the oxygen sensors got to be at 600 degrees before it'll work. Even if it's one of them other wideband sensors, it's going to be 1400 degrees. It's going to be really, really, really hot. And so it's comparing the oxygen out here. It's got a hollow ceramic zirconia bulb. It's comparing the oxygen in the air to what's in the exhaust, and it's calibrated so that if the exhaust is lean, if it sees a lot of oxygen in the exhaust, it's going to have low voltage. That it's producing its own voltage. You see, you can get a torch out there with a scope like we do and make it produce voltage. Okay, so the long and short of it is, if you've got a misfiring cylinder and you've also got lean codes, don't go after a lean code like you're trying to find vacuum leaks and stuff until you fix the misfiring cylinder. You're wasting your time throwing oxygen sensors and all this other stuff at it if you got a misfiring cylinder. So go after that. Okay, so I shifted gears here, and I was thinking about back when I worked at a dealership, the rear passenger side of the engine compartment in these particular vehicles, there's a heater hose clamp. It's the heater hose carrying water, and there's a clamp on it that's directly above cylinder number 4. All right, and this, whenever you would see that clamp, and you always had to suspect if the clamp and the hose are new, that somebody didn't quite tighten that clamp enough. Like on this, you're thinking about this Crown Victoria that them guys just left the clamp loose, and we were riveting it up yesterday, and it blew that thing off and it splattered. Well, these other ones will just drip. And where do they drip? They drip right on that coil. Isn't that something? All right, so with the light trained on a spark plug wire boot underneath that particular hose, the coolant stain all over it. They had been dripping antifreeze right there on that number 4 spark plug. The clamp looked tight, but with the pressure rising in the cooling system, a drop every few minutes is enough to compromise that particular spark plug. If it drips water down in that hole, say that antifreeze and all, and its boot. Well, the spark plug, we pulled it out, we removed the number 4 spark plug, and it was a greasy, wet mess. It was a nasty, greasy thing. And so the spark plug boot was the same way. Well, it was easier for the spark to travel through all this wet stuff than to punch through the compressed air and gasoline inside the combustion chamber. Well, the spark plug and wire replaced and the hose clamp tight. We fixed a couple of minor vacuum leaks and got the fuel trim readings right back where they were supposed to be. Everything was smooth. Well, anytime you're fixing anything that's got fuel trim problems, let's go, what do you look for first? And this is important, guys, for engine performance. I'm looking, if I've got suspecting that my fuel trims are like they are, Okay, looking at long fuel trim and short fuel trim. Okay, so long fuel trim and short fuel trim. I'm going to be looking at my long fuel trim first, because if it's had time to do an adaptive learning thing, it's going to bend the long fuel trim far enough out of line so that the short fuel trim comes back to zero. Right? And this scale runs from like minus 35 to plus 35. Minus 35 means it's subtracting fuel, plus 35 means it's adding fuel. You got me?
It works on the same principle as those two little screws on like a little carburetor for a chainsaw or something.
Very similar, yeah. Yeah, well, sort of. Yeah, that's what you're doing. It's doing the same thing, except it's doing it electronically by changing injector pulse width just mildly. Okay, let's say your long fuel trim is at plus 25%. And I'm just putting that number up there because you see that. If this gets out of single digits, I'm worried about it. If it's between 0 and 10, I'm not going to be bothered a whole lot. But when it starts to get above 10, I'm wondering what's going on, because there's something causing that. Now, the other day, Derek pulled the fuel trims on that that big old Chevy van with a 350 in it. It was a 2000 model. And I said, plug in your scan tool and look at his fuel trims on that. And he had fuel trims that were up around 20%. And I said, okay, Derek, I need you to find out why those fuel trims are at 20%. And sometimes, I'm telling you, the least little thing can throw this out of balance. You can take the oil filler cap off, and those fuel trims will start to walk. That's how sensitive that is. Well, Derek, I told him to get the smoke machine and see if it had an intake leak. Well, before he even got to that point, he said, I found the problem. I said, what'd you find? He said, the PCV closure hose is supposed to, your PCV's on one side and this hose going to the breathers on the other side. He said, somebody left that unhooked, or it came loose or something. And so when he put it back in there, that fuel trim walked right back to zero. But what I started to say was, let's say that you've got a situation like this. And let's say that you find a split vacuum line or something wrong or whatever, and you're going to fix it. Be taking notes there, Will. All right, so you're going to fix this thing. After you fix your leak, while you're doing your fix, this is a smart thing, pull your battery cable off. Go ahead and clean your throttle body. Just make sure you got a sludge out of there so it'll idle good when you come. Because the throttle, it'll have learned to idle right with sludge in the throttle body. And sometimes when you pull the battery cable off and put it back on, it won't idle for a little bit, or it idles too slow. If you go ahead and wash that out, use your toothbrush and your carburetor spray to clean it out real good. Okay, put it back on. When you first put it back on, both of these will be right here to begin with until it closes loop. Watch it, and when it closes loop, that means it's paying attention to the oxygen sensors. Closed loop means it's paying attention to the oxygen sensors. Open loop means it's figuring on everything else and it's ignoring the oxygen sensor. Now remember the difference between open and closed loop. I'd been in the field. I knew for 6 or 8 or 9 years what open and closed loop was, but both of the two supervisors at that one shop I worked at didn't know what that meant, and they've been doing this work for a while. All right. As soon as that thing closes loop, you need to be watching that short fuel trim, because it's the one that's going to react first, okay? Okay, so if I see this short fuel trim pretty well staying close to zero after it closes loop, I'm done fixing my problem. If, however, I see this short fuel trim beginning to walk, if it starts walking back up, and what will happen is it'll go 2, 4, 6, 8, 10, 12, 15. If it goes up to 20, 25, 26, and it gets to the point where it's got short fuel trim so far out of balance, and it's using oxygen sensors to decide, see. And what causes that is, it's in closed loop, but the oxygen sensor reading lean because there's still some air going in there that doesn't belong. And it starts trying to keep adding fuel because it wants to see this. And it's going to do whatever it has to see that oxygen sensor do that. You see what I'm saying? All right. And this is part of your engine performance stuff now, because it's really important you understand this, because it's real solid information. All right. This short fuel trim, if it starts walking up, it's going to start, this will begin to go up. This will go 2, 5, real slow. And as this gets up, if this goes back up to where it manages to keep this, then this will wind up on 0 again. But you want them both to stay right there close on either side of 0, and that way you know you got it fixed. See what I'm saying? That's how you verify your repair in a situation like this. You don't put it out and let it go down the road and her come back 2 days later saying, my light came back on, now I got another lean code. Why didn't you catch it the first time? I'm not paying you another diagnostic, and whatever you fixed before didn't fix it, and I think you sold me something I didn't need, and blah, 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 you know, with all due respect. But if you do a good job verifying the repair, you know.
How much adjustment does the short fuel trims have to make and maintain before the long fuel trims?
Usually when it breaks over 20%, and if it stays up there, and it can go to the point to where if the long fuel trim is bent far enough out of line, like I think about 30% or something like that, it depends varies a little from car to car. It'll say, like if it's a lean adaptive limit reached or rich adaptive limit reached. You see, depending on which way it went. But usually when it gets up between 20 and 30, in there is when things start to change. You know, one way or another, we do that. So, if a short fuel trim starts swinging back toward the previous correction, whether it was positive or negative, we're not done with the repair, and it may be time to break out the smoke machine or whatever. Okay, now then, let's do a fluid transfer thing here. That fluid transfer was talking about coolant dripping on the spark plug and causing it to quit. Of course, we had to tie that clamp too. Here's the other thing. What if I just went in there and I pull that plug wire out, and I pull the plug out, and I clean the hole out, and I replace the plug, and I put a new plug wire on it without fixing what caused it? It's going to come back just like it would. So figure out as near as you can what caused it. Occasionally, somebody will wash the dadgum engine with a pressure washer, and stuff will get down in there, and it rusts the plugs and all that kind of stuff. So you definitely need to know what caused it in as much as you can. Sometimes if you don't see anything and you've looked, done your homework and looked, then that's other. You just got to fix what you find and tell them, I don't know what caused it. Well, let's see if it happens again. This guy called me, your forestry instructor there. His concern was fuel economy and power related. And a Dodge Ram is what he had. That 5.9 liter in that Dodge Ram is not a fuel miser anyway. It's going to suck gas. But he was noticing that on his gas mileage display that his mileage had plummeted.
Yeah.
Okay, now let's see if we can figure out where this is going. Our initial test drive revealed nothing particularly noticeable. We could drive it and it seemed pretty much feel normal. The transmission fluid needed to be changed. It was really dark and ugly. And we scanned tool the data stream, and we had a sluggish oxygen sensor. Now here's what I'm talking about there. Sluggish oxygen sensor is one that, a good one is going to look like this. A sluggish one is going to look like that. And some of them will actually tell you that it's a sluggish oxygen sensor. They have a code on some of them. And I will tell you this. Sometimes on these Dodges, and I've seen this a bunch of times, it would go up there and it'll hang at just above 0.5, which is actually what's considered rich. And it'll just hang right there. And it won't go anywhere because it's got a bad oxygen sensor. And what the controller's doing is it takes the fuel trim numbers and starts trying to yank it back down. And when it yanks it back down, the engine starts running so bad, the truck opens loop. And then it'll yank it back. And this happens so fast, you'll actually see a fuel trim graph, if you graph the fuel trim, that looks like a sawtooth. I mean, just boom, 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 boom. And if you see that oxygen sensor hung at 0.6 of a volt, and this nonsense here going on, and it's acting like a bucking Bronco, then you need an oxygen sensor. And I've seen them just about quit going down the road because of that hogwash. And I don't know of any of the rest of the cars that do that. But they can, if they hang, where they're rich. Usually when an oxygen sensor fails, it goes lean. But on these Dodges, it feeds current out to the oxygen sensor. When you first fire up a Dodge and you're looking at the scan tool, the ones I'm talking about here, you're going to see 5 volts. And then as that oxygen sensor heats up, that voltage is going to go down, and when it gets below 1 volt, it starts switching normally between 0 and 1 volt. And that's your PCM's way of checking that oxygen sensor. And something else that's spooky about a Dodge is in the middle of the night, it will wake up and say, I think since they haven't been driving for a while, I'll check the oxygen sensor heaters. Boom, it turns them on and it measures to see if they get hot. And if it does, it shuts down. You may just do that while you're sleeping, while you're snoozing or watching your movie, or all your Dodges out here checking its O2 sensors. I mean, they just do that. They've also got natural vacuum leak detection, where they say if the thing's been set in so many hours, if it's cooling down, the pressure in the gas tank should change. If it doesn't change, I know there's a leak. It's a sort of like a passive leak detection thing. They're pretty sharp about that kind of stuff.
That
All right.
Dodge thing or just Chrysler in general?
Well, the natural vacuum leak detection thing is the NVLD is a Chrysler thing that I first saw on Chrysler. I can't say who's putting what on them now, on the newest ones, but that's everybody's trying to come up with some kind of a better way to do it where they have to use less hardware or something that's more reliable and all that. So you're just about going to have to go from car to car, research that. You go to your description and operation if you're reading out of a good shop manual thing, find out how it works before you go diving in there trying to fix anything. You'll change a bunch of unnecessary parts. And you'll find that in the description and operation section, see. Unless it's a European car and they expect you to know it. Because you've got to be a journeyman and an apprentice and all that over there before you ever work on cars. Okay, we checked and said we looked at his the rounded off spark plugs that he had wore out. The scope tested with a lot of resistance in plugs. He snapped, accelerated, and the spark went off. So it had a freshly cleaned air filter and the fuel pressure was normal. And we checked the tire pressure. I say freshly cleaned; it was a fresh, clean air filter. We checked the tire pressure. That's an important thing to check when you're worried about fuel economy, right? For tire pressure. Now, sometimes when I was at the dealership, people would come and say, the sticker on the window of this thing says it's supposed to get 19 miles to the gallon, and I'm only getting 18 and a half, and I want you to do something to fix that. Excuse me. You know what I did the other day with a couple of guys? I did a placebo thing. I had this neat-looking little thing that I got from a little robot wire harness. And it was a little hinge thing, with a little ferrous metal thing in the middle to, keep electrical interference down. And I snapped it around their fuel line. I says, try this. This is supposed to help your gas mileage. A couple of the high school guys. And I snapped it on there. And I says, just give me a report on that. I said, I'll let you use this for a few days, but give me back to me when you're through. And he came back and he goes, it got really good gas mileage for the first half tank. And I said, really? Well, why did it do that? If somebody's checking their gas mileage because you put a fancy device on their vehicle, they're going to drive more careful. They're not going to take off quite as aggressively, and they're by default going to get better gas mileage. Unless they forget it's on there and they just start driving like they used to. You know what I mean? But Gene Taylor, bless his heart, he did that. He found one of these things that somebody sent him through the mail and put it on the fuel line on one of his vehicles. He swore up and down. It got him another 2 miles to the gallon. If you give some hoodoo about it, say, how does this thing help gas mileage? Well, it aligns the molecules in the gasoline where they're going in there straighter or something like that. You could wire up a box with a blinking red light on it and say, try this out and see how it works. And about 6 out of 10 people will come back and say it helped their gas mileage when it wasn't doing anything. But see if you can trick them into driving the way they ought to drive instead of just digging out when they take off. They'd be surprised what a difference it makes gas mileage. Okay. Now then, he got a brush guard. What's that do? Catches the winds, hurts your gas mileage. Roof racks, brush guards, running boards, mud flaps, all that stuff's going to catch the wind and slow you down a little bit. Okay, but it still drove good, didn't have any obvious issues, so we gave it back to George and he paid his bill and drove away. Well, for the first day, everything was fine, he said, but then he called back and says, well, it doesn't have the power and speed it's supposed to have now, and now I'm noticing I'm losing some power. And he says, and I also noticed, now here's a key. This is a piece of information that we never thought about. He says, when I walked by the truck, I noticed that the front brakes were kind of hot. Now think about that. Okay, well, get it back over here. So we got it back over there. And so whenever he asked about the rubber hoses leading out to the calipers because sometimes, they can collapse on the inside, especially if somebody takes the caliper loose and lets the disc caliper hang by the hose. And that happens all the time. You're supposed to do that. If you do that, it's sometimes it tears the hose on the inside and then the hose swells shut, and this kind of thing. So anyway, rebuilt calipers were $15. And we did notice that when we wound up getting, we drove it. Now listen, how do we do it? We raised it up, and we drove it, stopped, drove it, stopped, and then we raised it up. And we turned the wheels, and they seemed to turn pretty good. And we mashed the brakes a few times, and then they got to where they wouldn't release. You know what I mean? So usually what you do is you loosen the bleeder screw. And if you loosen the bleeder screw lets them release, then you know that the fluid's trapped back up the line somewhere. You got me? If you loosen the bleeder screw and they stay stuck, then the calipers are bad. That make sense? Okay, so his calipers he wanted to go ahead and put some on there and put hoses in there. That was his idea. Let's do that. And I said, all right, we'll do that. And he was the brake pads were getting kind of thin, so we machined his rotors and did all this stuff. He put it all back together. But he told me something else that was very interesting too, that somehow got past me. He said, I've had to add brake fluid periodically for the last couple of months because I keep going low on brake fluid. Well, you look under the truck everywhere. I didn't see no brake fluid nowhere. Couldn't see under here where anything was leaking. Just looking at your points where the thing was going. But he had another brake issue with the new calipers and everything on it. And so what happened was we took the master cylinder off and we looked in the booster and it was about half full of fluid. The brake booster, the brake master cylinder was leaking and that fluid was going back into the booster. And you don't see that a lot. That's really kind of odd. You know what I mean? But that was causing it to have this problem, with a brake booster half full of fluid, and it causing issues with that big rubber diaphragm and all that. So we actually poured about, I'm going to say probably 1.5 quarts of fluid out of his booster. We took the booster off and turned it over a drain pan. I got pictures of it in this article here. It just poured all kinds out there. And then we had this Chrysler Sebring, and this is the last one we're going to talk about. It was losing coolant. And the woman that owned it had been adding clear water until she'd almost completely diluted the coolant and had clear water in there. And we had a low 20s cold snap, and she came in with her coolant level low and an overheating problem. So we filled the coolant system up and we put pressure on it, and it looked like a rainstorm coming from both ends of the engine. Just water running out of that darn thing everywhere. And one of the worst leak was coming from between the transaxle and the engine. And so I had this picture in my mind of nasty cracks in the block or maybe pushed out expansion plugs because, water when it freezes expands 9% by volume and it'll push out expansion plugs. You don't really call those freeze plugs. You call them expansion plugs. So I had a couple of guys yank the transaxle and the flywheel off and we pressure tested again. And there's a little hole in the end of the valley. The out of valley between the two V's. There's a little hole in there and water was running out of there. Well, on that particular vehicle, and I'm going to show you all a picture or two before we wind this up. It was pretty interesting stuff here. The water pump on that 2.7 liter Chrysler Sebring is driven by the timing chain, and it's difficult when you look at that when it's got that sideways 2.7 in it. It's very difficult to see how you could replace that water pump without pulling the motor out because it's in there where you can't get to it. I mean, it's got like no room between the shock tower and the engine. All right, look at this right here. You see that little hole right there? See that little hole right there? I'm going to turn that around so that this camera can see that too. That little hole that you see right there is actually, they don't want the water pump leaking into the timing area. So what they do is, they put this particular, I got that silly mouse hand on that. They put this particular hole right here by the thermostat, and whenever the water pump leaks, there's a little passage drilled down there that's supposed to let the water pump leak here. Well, the passage on her car was clogged up with dirt, and that happens a lot. There's another hole in the valley between the heads, and this hole wasn't letting any water out, so water was coming out of that valley. You're supposed to clean that out. It's on the side of the block down there under the air conditioning pressure. If you do this. Anyway, the water was coming out of the other hole because it couldn't come out of this hole, and it was running down through the valley and out the back. Now, you also got to be careful on these because sometimes that little part on the top of that 2.7 has got a bleeder valve on it that the hose is hooked to. That thing can leak, and it'll make you think something's leaking and it's not leaking, so be extremely careful about that because it's plastic and it routinely leaks. It costs about $50 to buy that part. But anyway, on that 2.7 liter, we wound up having to pull it. The timing chain drives the water pump. So we had to pull the motor out of that one and put a water pump on it and put it back together. She drives it every day now, basically. But anyway, that pretty well when I did it. I'm going to go up here and show you another picture. See that spark plug? That's what came out of that number 4 hole.
Now, is that the same problem as the one you referred to when you tell that story about commonly the commonly failing spark plug on cylinder 4 on those Explorers?
No, that was a different problem. It didn't have water leaking onto those. But cylinder 4 on those Explorers was the front one on the left side because it was a V6. This one was the back one on the right side because it's a V8. But yeah, that other one, I had no clue why those Explorer spark plugs were failing. It didn't make any sense to me, but it happened a lot. All right, now, see this hole right here? There was water coming out of that hole when we had our transmission back. That's what we saw there. But there's that dirty spark plug, and I had another couple of pictures here too. I'm going to show you. See the stain, the coolant stain on that plug? That's a telltale. If it's got a stain on it where antifreeze has been on there, and that antifreeze will leave the color of itself there. And that was that spark plug, and when we pulled it out, we found that greasy mess in there. And there's another picture over there. That hose, there's a hose that goes above it that drip. Actually, this is sideways. They fouled that picture up. This is actually supposed to be like that with that clamp. See, this is actually above. It should be up here. That clamp right there was loose, and it drips right there. You see. I mean, this is actually the initial copy they sent back to me. Look what we poured out of his brake booster. I mean, I had the camera ready. We took a picture of when we poured that stuff out of there. I mean, that's George's brake booster. All right, now right here, it's kind of difficult to see, but right here, you see that wet right there? That's the reflection of that spring in that brake fluid. That's how much was in there. When we pull the brake master cylinder off, you could look down in that brake booster and see that it had a lot of liquid almost up to that hole. And that was what was causing his other stuff, you see. And that's the truck right there, that we had. See the big brush guard on it? Now this really looks like a gas saver, doesn't it? That truck, just looking at it, you can tell it really saves gas, All right, but anyway, yeah. All right, anybody got any questions about that?